I will show you the problems in a moment. The formal title of the presentation is the two typographic etudes. But when we prepared the talk, it appeared that there will be 4 typographic etudes. Etude is something that musicians usually use to practice. And etudes are usually boring because it's boring stuff. You just play and play and play and play and but it is boring, but you are getting better in the topic that you are practicing in. So we hope that we practice a little and we will show you some results of our practice. In fact, they are the results of our experiments, because we always make experiments in what we do. And the experiment will be somehow connected with user interface and typography. User interface is something like this. This is a user interface to a submarine. Submarine, some 100 years old, and as you can see, the user interface is rather complicated. So there are lots of wings to use. But this user interface is not only difficult to use, not only complicated, but also it is not possible to prepare your own version of this user interface. You cannot come here and make your own wheel that will steer a few wheels at the same time. There are no programmability here. You cannot write a program that will translate your user interface to this user interface.
You could use a Chinese computer.
There were no Chinese computers at this time. And the other very important feature of this user interface is something that we call a list of options. So no programmability, but you have list of options, only menu, and you can use either this option or this option and nothing else. But all the complicated stuff is hidden to you, and you can use only this. So we will deal today with user interfaces, typography, list of options, and programmability.
And servicing of such user interface is hard to.
Yeah.
If there is a leak, it's hard to find where is the leak. But always you can use a hammer.
Probably, yeah. So we start from the first experiment, the first etude, the first thing that we wanted to practice, even before we started to work on the stuff that Łukasz suggested to us. So we start from something very trivial, which is a Bézier curve, which probably most of you know what it is. It is just a single arc, and usually in most of the programs that we can use, such Bézier curve can be manipulated using some menu, which is here. On the left-hand side, you have a set of tools which is the same as the wheels in the submarine. You have only a selected number of objects that can be manipulated here. The objects include something like Bézier curve, also include something like a square or a circle, but it's only a limited selection of objects. Here we have a pre-prepared object like a Bézier curve, but not only this. We have a curve, but also we have some points that are shown here. You have some dashed lines. You have some numbers here and here and here. You have here t equals 0.5, denoting the point of the curve where is some kind of middle of the curve. But everything here has some logical intention in it. There is some logic in this picture, but this logic cannot be reflected in programs like Inkscape. This is in fact in Inkscape. So if you work a lot and prepare a picture like this, then you can go to menu. You can go to one point of menu, and you can click on this, and now you can see that what Inkscape displays is perfectly the segments here, and you can catch it and manipulate using your mouse or touchpad. So you can catch here and change the shape of the curve, right? But all the logic is gone. You change the shape of the curve, and the description of the point stays here. The points here stays in the same place, and all the work that has been done very precisely to make the position of the number exactly on the dissection of the angle, all the work is gone because it's useless now. So if we want to manipulate such an object that has a logical structure in it, we need some more tools, and it would be nice to make a program that produces such an object, right? So it would be nice to express all the logic inside this object in a programming language. And we here know that such a programming language is, for example, MetaPost. MetaPost is a perfect language for preparing pictures like this. So we can write a program in the MetaPost language. We can call it trivial.mp. And this is actually a real program that has been used to produce a picture exactly like this.
Contains
some basic stuff.
And 4 screens.
Just 4 screens. Yeah. I can show you all of the program. That's it. That's it. Nothing else. Right? Everything in MetaPost.
And most of them are trivial settings.
Yeah, absolutely. And also a small file with only parameters to this picture, because this logical result that the picture can present, the logical result is the result of computation, and the input to this computation is a set of points. In this case, there are 2 points at the end of the arc and 2 points, 2 control points. So the control points and all the points we can write like this as the input to the picture, and the result is exactly this. So the same picture achieved in 2 possible ways. The first was without logical structure, but with the possibility of manipulating it, and the other one is with the logical structure, but what usually we receive at the end is a static object. It's just a static graphic. But this is an experiment, so in our case it is not static. You can catch every point and change the picture, right? And all the logical structure is preserved. So everything, including the positions of the numbers, the positions are always as the bisection of the angle, and the position of this text, which is perfectly
tangential. Styczne.
Tangent.
Yeah, to the point, and the point is recalculated and so on. So MetaPost really allows us to use the logical structure, and the picture here is actually produced by MetaPost, which is run some 30 times per second to produce such a result. This picture was prepared by us in, I don't know, a few hours, half a day, writing the program in MetaPost, which was done by Jackowski, and the user interface, which was already done by me. So that's the trivial example. That's what we know that might be possible to combine in one program, to combine programmability and the possibility of interacting via graphical user interface, right? Responsive object, yeah, responsive typographic object, or yeah. Okay. The second etude, when we were ready with this, there came the idea that it should be possible to see, to watch what I was always dreaming to see from the beginning of my work with tech, which was in 1987, so some 20 something years ago. I was always dreaming to see how the line breaking algorithm is really working. So we prepared an example like this. This is just just 2 or 3 paragraphs in tech, perfectly broken into lines. This is the text joke, you know, the positions of letters in the words are changed. But anyway, this is the text, and I wanted always to see how it is, how tech does it. So we prepared a sensor here, and you can just catch it and move horizontally, right? Like this. So you can see how actually tech does it, right? But it is not only the tech working, because just line breaking algorithm would be the same as in every text editor, nothing special. But what is special about tech is that you can express, using a programming language, you can express anything you want. So we wanted here to express the fact that when the h size, when the size of the column became narrower, the algorithms change, the parameters of the algorithm change, and it changes from right justified to rugged right. Bless you. So when we go narrower and narrower, in some point it changes from right justified to rugged right, to make the spacing more unique. Right? And we can go all the way.
Na niektórych stronach internetowych to się przydało.
Yeah, but this is the full power of tech. This is not the same as in the web browser or text editor. You have the full power of everything that is possible in tech, including math formulas and so on, and musical notes and whatever. So this was our second etude when we prepared to deal with puzzles that were given to us by Łukasz. The third etude is a bit more complicated, because when we are able to program something in a programming language and to have a user interface to this program, then the whole new world opens. Then you can express in your program anything you want and practice with it to see the results. So Łukasz a few weeks ago or 2 months ago wrote to Jackowski some question concerning one of his problems when he designs letters or designs computer fonts. He is a master of it. You know. His font Lato just reached 10 billion
questions.
10 billion of users in the world, more than people in the world. So this was the problem, if I understand it right. You have 2 curves, two Bézier arcs with the control points like here, and the task is to connect them in such a way that the curvature is as smooth as possible, but also to to find a point that will have a feature that the curvature on the left and on the right will be the same. So this was the task, and obviously doing it like this is not correct, but doing it like this is quite perfect, and the control points of the Bézier are to be preserved. So the control points are input to our problem, and the result is finding the point. This was important for some letter designs where the points are to be found that has curvature the same on both sides of the points. So again, this time Jackowski started and wrote mathematical theory about this problem. The mathematical theory was in one of the articles that are not in the proceedings because of some mistakes, but all the papers that were missing in the proceedings are here. I will hand it around, but not at this moment.
For people interested in such rubbish.
If you are interested in the mathematical foundation of the solving the algorithm. But anyway, this is the article. But in the article there were obviously some examples shown, and examples had to be static because the paper is static and you cannot move any pieces of the picture in the paper. But here is not the paper. Here we have a presentation, a computer presentation. So the very same program that was used to generate the examples, the same program with some input data called sensors. You know why. So some input data and the program resulted in a picture that is here. And in this picture, the points numbered with red color are input data. So 1, 2, 3, 4, 5. And the points 6. Thank you. And the points 1, 2, and 3 in black are the result of the computation. And the result is to be like this, that in every black point, the curvature on the left and on the right is to be the same, is to be equal. The algorithm works like this, that when we move any of the red points, the black points are recalculated. But it is funny that when you, for example, move the point number 2, it influences the point number 2 black and point number 1, but not point number 3. You can see it working, obviously. So we can play with it. Watch the point number 2 black and number 3 black. Right? They are moving. So it is not the same as in CorelDRAW or Inkscape or whatever. This is just a new algorithm. And watch also that the point number 1 black is not moving. That's the feature of the algorithm. So we can just play and observe how it works. That's MetaPost. Nothing else, but it's much easier to manipulate the result of MetaPost in a way like this than to write a series of tests to produce 20 pages of PDF files and compare them and so on. This is much easier, I guess.
Do you output the resulting values for 1, 2, and 3?
The resulting values, yeah, they are written on a disk in a file, and you can use it. So obviously,
you can then reproduce the same shape whenever you want.
Yeah, this is not the product. This is the experimental version of a presentation program, obviously. But in something that could be a product, one could probably use Ctrl S or some menu, some option. To write in a file a perfect combination of all the parameters. All the parameters are now in this very moment on a disk, because this file is generated every time the new picture is displayed. So that was the etude number 3. The etude number 4 was even more complicated, at least for us. It has more input data. The etude was inspired again by Łukasz, who worked on shapes of letters and observed that what mostly influenced the curvature here, changing here, what influences is the proportion between 3 segments that are here, and the segments are the endpoint of Bézier curve and endpoint of Bézier curve here. And here is a segment that joins the 2 control points. So we have 3 points and the same proportion here, and it makes quite a nice curve. Here are how Łukasz worked with various proportions, but probably it is much easier to work with the proportions having interactive possibility of changing the values of them. So we prepared again a program in MetaPost based on Jackowski's theory. The paper that we will hand you around contained not only mathematics that stand behind it, but also several pictures which had to be many of them here, because you cannot manipulate the...
Not yet.
Yet. On the paper. Yeah, probably in future we will hand you around some papers with the possibility of moving, but next year. So it was not possible yet in the proceedings to publish a version with moving objects. So there are many of them here. But the program in MetaPost that was used, again, several screens of the text, that was used to generate the examples.
A little bit longer.
A little bit longer, a little bit complicated. Again, some sensors that are values, input values to the picture. And the picture is also a bit more complicated, and let me explain a few elements of this picture. We have a single Bézier arc with 2 angles that are defined by 2 points that show what is the angle. The angle is displayed here, alpha, and the second angle is displayed here. And the length of a segment P0 to P1, we define this length as 1, and P1, P2 we define as P, which is 0.5. That means that this segment is twice as short as the first one. And the length of P2, P3 is Q, so it is 1.33 of the length of the first segment, right? So this is the way how we can define the proportions of 3 segments, and the proportions are displayed here, and we decided to design a special way of giving the values, and we have a square here. The square is meant to define both the values. Here is the point 0, 0, 0. Here is point 2, 2. So when we move some point from 0 to 2 and from 0 to 2, the coordinates of this point show the values of P and Q, which are the values of the proportions here.
Najmniejsza wartość nie jest 0.
Close to 0, 0.
0, 2.
Okay. And in this picture we have in fact three input data, which are 3 input points. The points that define the angles, and the point that defines the 2 elements of the proportion, the P and Q. Obviously there are no programs that you can buy and that contain in the menu, in the list of options, such an object. You have to be able to program such an object yourself. So obviously in this picture everything can be moved. So you can move the angle, the first angle, you can move the second angle, and note that the proportions are kept. So as I move the second angle, the proportions are kept and the control points are recalculated. This is in the case of the proportions that are already displayed, but you can catch also the sensor here, which is the sensor that's defining proportions, and you can move to the right, for example. When you move to the right, the proportion, the value P is rising, so the middle segment is getting bigger and the other are proportionally smaller, right? When you go vertically, the proportion changes like this, right? Because the point, the P is 1.2 now, Q is 166, and it's Q that mostly changes. So what changes is the length of the last segment. And you can play, of course. This is what I like to do. I just sit hour and hour and just play with it because it's just fun. It was the first time in my life when we prepared this presentation, it was the first time in my life when I could really see working metafont with changing values and observe the result. The same with tech. So after some 25 or 28 years of using tech, I really managed to see. And we especially prepared those examples in such a way that you can see the tech here, the points, the positions of labels that also move. And everything is in the typesetting computer modern, just to tell, yes, this is tech and this is really metapost and nothing else. So that was the fourth etude. And after doing this, we started to think, so what? What is the conclusion of the fact that it is possible to write such programs? So we have several conclusions that we can briefly and shortly describe. The first is what I told you at the beginning, that the usual paradigm is that when something is interactive, then there must be a list of options. Like in the Inkscape program, or like in the submarine, where you have also a list of options. So it was so far like this, and also the opposite. It was possible to have a programmable graphic or programmable typography like in tech and metapost, but then you have to run it from the command line, so there is no interactivity. What we hope we were able to show using these examples of using these etudes, that it might be possible to have programs that are interactive and programmable at the same time. It is possible at the experimental level. It is not a working product that we can give you and tell you, use it and play with it. But the experiment shows that it might be possible, probably. So we can work towards making a product, a program that would have such features. Another thing, what is important here, it is that we not only have this interactivity at the stage of preparing the final document, like when Łukasz works with fonts, he is working with something that is moving, but the final result is a font. Font is a finite collection of glyphs, and every glyph is a static typographic object. Glyphs are not changing their shapes according to situation or according to some parameters. But here, what we present in this presentation, the very presentation is a final document somehow. We, of course, when we worked on the presentation, we had the dynamic possibilities, but also the final result is a dynamic object that remembers and uses its logical structure. So on several pages of this presentation, there was not so that I could do everything I want. I had just selected and perfectly defined by someone, by us, perfectly defined ways of using it. So I gave the user is me now, I gave the user the possibility of using only several ways of interacting well defined. So still the final document may be safe in a way that we can define what the user can do with this final document. It could be also on, I don't know, on web pages, for example, where the interaction would be changing the size of the screen, or on tablets for reading books or watching such graphics where one can change the position of the tablet. So the remembering the logical structure seems to be very important. And what we have here is the interactive and dynamic final document. So our hope is that working on this etudes, we go a little bit from the era of user interfaces that are stiff and contain list of options to something that would be hopefully a little bigger fun. So if submarines, then submarines like this, hopefully. So have fun in future, I hope. Thank you. That's all.
Byłeś za szybki.
We have plenty of time for questions.
Yeah.
Or comments. Anyone?
Sorry for keeping this so short, but we were working so hard that we thought that it's a lot of stuff, but it was a lot of preparations, and now it's simple, you know. Just
I know that this is not a part of the main topic, and this is not that interesting in this, but what do you use for the graphical interface? I know that there's tech and metaphors underneath. What do you use on top?
On top there is some Python modules using GTK+, but all the user interface is defined in some abstract ways, so GTK+ is hidden in the middle of this. There is some abstraction level, and the interface, like the presentation, is defined in terms that are independent on the actual implementation, and I hope that this abstract level will implement it in the same way based on some other graphic languages like JavaScript in web browser, or Qt in anything, or Java in smartphones, in Android, and whatever. So there is separation between levels.
No teraz tym przy pomocy tego to te problemy, co to Jean-Michel zgłaszał dzisiaj, to ty rozwiążesz.
Tak, łapiemy za nutkę i przesuwamy.
Zupełnie poważnie. Tę stronę my myślimy.
Andrzej asked about musical notes. we are working on a big musical note system, so obviously it is constructed internally using some wise characters, or characters that know how to behave, how to change according to the circumstances, which is essential in musical note typesetting. And obviously it hopefully will be possible to influence such typesetting using some sensors, some user input by moving musical notes, but still preserving the structure. So the final result of music typesetting should be a document that still knows its internal structure and can adjust to the size, for example, of the media, like to the size of the screen or the orientation of the screen and so on. So we work in such a way that the logical structure will be included in the final document.
Well, I have this question that you described the way you were working. Łukasz formulated the problems, Jackowski made this theory, and you actually implemented it. I have a question to Łukasz. Are you able to understand the internals of the MetaPost program and Jackowski's presentation program?
Not yet, indeed. So I have my own implementation of the Objective-C of this program.
Łukasz gave us this problem. The problem has been solved, but Łukasz wrote his own implementation. Łukasz is not only a perfect designer of fonts, but also a great programmer. So he wrote his own implementation, in fact, at the same time that we are preparing the presentation. So
based on the theory, theory.
But not in MetaPost. I don't know MetaPost.
No, a w czym napisałeś?
Objective-C. Objective-C and Python.
A dołączyłeś do czego? Bo używasz jakiego programu?
Macro in Python for FontLab.
And final interactive tool was FontLab.
It's not. FontLab does not allow to be interactive. It's just I have to, when I had to set this point as a smooth point, I have to run macro. It's not automatically, but I have another implementation where it happens magically online if I drag the points, something like this.
If you have implemented in Objective-C, do you have an application for iOS which does the same?
Not exactly, because the graphic Objective. Okay, I can explain you, but it's a difference between iOS graphic stuff and macOS graphic stuff, and it's a bit different. It's pity there's no in these two etudes there is no one etude connecting both problems, because in this moment it could be visible how it works with the dynamic of the curve.
Yeah.
Next question is from Marek.
When you show the paragraphs that we're changing as you move the box, I'm not a programmer, but what's happening there? Do you have you got? Is it full tech running behind there? What's
yeah, it is
how
full,
is it that it's so far?
Yeah, it is full tech running. In fact, it is MetaPost using tech. So on the first level there is MetaPost, and MetaPost calls tech. So both systems are run every single frame here. So some 30 times a second are both programs used and recalculate everything from scratch.
But there are few algorithms from tech used, so it's not necessary full tech to be run. It can be some algorithm extracted to work on it, and some algorithms can be implemented in Python or in some other language and used in this case.
Yeah. Jackowski just reminded me to tell you one more step in the implementation of all this. What MetaPost is doing here in all the 4 examples the MetaPost is producing the SVG file. SVG is the
newest version of MetaPost.
The newest version of MetaPost, yeah, 1.801.
Something more.
And with changes done by Piotr, because we discovered in all the versions of MetaPost, the recent versions, there were some problems. So one of the problems were overcome by Piotr by finding what to do with the colors, because the colors were wrong. Now it's okay. It's required to change one line in the MetaPost program. So what is working here is the MetaPost from the last week, changed by Piotr. And the SVG is directly rendered here by GTK Plus and Cairo mechanisms. So it works like this.
A jak to wpływa na temperaturę? Po procesorach.
Prawdopodobnie procesor pracuje na najwyższych obrotach. Jak na laptop, to naprawdę to, że się wyrabia, to jest tam pełen szacunku dla firmy, która...
Zawsze można użyć Intela 4-rdzeniowego.
Chciałem tylko skomentować. I would like to comment the topic that was touched by Marek in his presentation, that we think about making products out of it. One that I would like to have is just a visualization for MetaPost. We are not far from it, which doesn't mean that it's simple, but you can see that in principle it's not possible. And now we have to think about how to do it general enough to be possible to attach every program prepared in a special way, but to a general visualization machine. Yeah? So such an educational tool would be, I believe, could be of interest for potential students of MetaPost, for example. Just a comment.
Do we have more questions?
To mamy długą przerwę.
Well, if
15
not,
minut.
let's thanks again the speakers.